When you try to picture the beginning of everything, what do you see? You probably imagine some colossal explosion, right? A blinding flash of light. I mean, that's what most of us think. But the real story of our universe's origin, it's a lot stranger and honestly a lot quieter than you've been led to believe. Let's dive into how silence, of all things, built everything we see today. Okay, so first things first, let's just get this out of the way. The Big Bang wasn't some kind of giant explosion in space, like a firecracker going off in a huge empty room. No, it was the rapid expansion of space itself, everywhere, all at once. It sounds like a small difference, but trust me, it's everything.
And yeah, it definitely didn't bang. In the very beginning, there was just silence, complete and total silence. No sound, no light. You can't have an explosion in a void if there's no void to begin with, right? The universe was the expansion.
So this brings us to the big question, the real mystery here. If the universe started out so perfectly quiet and smooth, how in the world did we end up with all this? This messy, chaotic, beautiful cosmos filled with galaxies and stars and us. How did silence build everything?
To get to the bottom of it, we've got to start by fixing that name. It wasn't a bang. Think of it more like an incredible, super fast unfolding of the very fabric of space.
So what physicists call this moment is cosmic inflation. And when I say fast, I mean it's hard to even wrap your head around. In a fraction of a second so small it's basically meaningless to us. The universe went from being smaller than a single proton to a size so vast it's just impossible to comprehend. It was the ultimate growth spurt, and it set the stage for, well, everything. You know, the best way to visualize this is the classic balloon analogy. Just picture a bunch of dots drawn on the surface of a balloon. Now, as you blow it up, the dots all move away from each other, right? But they aren't flying across the rubber. The rubber itself, the space between them, is stretching. That is exactly what our universe is doing.
But here's the thing. This incredible expansion creates a huge puzzle. You'd expect an event that crazy to make a really lumpy, uneven universe. But instead, when we look back, the early universe was astonishingly, almost unbelievably smooth. A little too perfect, actually.
And how smooth are we talking? Well, the temperature from one spot to another only varied by less than 1 part in 100,000. It was like this perfectly uniform fog of energy, almost zero variation anywhere.
This quote really puts it in perspective. And here's why that's a problem. If everything was that perfectly smooth, gravity would have had nothing to latch onto, no little clumps to start pulling together. And that means no galaxies, no stars, no planets, no us. The universe would have just stayed a boring, featureless fog forever.
So something had to break that perfect silence. And the answer, incredibly, didn't come from the cosmos. It came from the absolute tiniest scales imaginable, the weird, wild world of quantum mechanics. It was like a whisper that came from nothing.
See, on our scale, empty space just looks, well, empty, calm, nothing there. But quantum physics tells a totally different story. Down there, it's this jittery, buzzing sea of uncertainty, with tiny little fluctuations of energy constantly popping into and out of existence.
And this is where it all clicks together. During that insane moment of cosmic inflation, these tiny microscopic quantum jitters got caught in the expansion and were stretched to absolutely astronomical sizes. These tiny, fleeting ripples suddenly became as big as oceans, creating the very first spots in the universe that were just a tiny bit denser than the areas around them.
And those tiny little seeds, that's all gravity needed to get to work. But it took a long, long time. For hundreds of millions of years, the universe was still completely dark. Astronomers have a great name for it, the cosmic dark ages.
And gravity is patient. For millions and millions of years, in total darkness, it just slowly, methodically pulled these enormous clouds of hydrogen and helium gas towards those slightly denser spots. And as the clouds grew bigger, they got hotter, denser, until finally, in one spot, the pressure got so intense that nuclear fusion ignited. The very first star was born, and its light finally broke the darkness. The cosmic dark ages were over.
You really can't overstate this. These first stars were total game changers. Inside their cores, they were like cosmic forges, creating the first heavy elements: carbon, oxygen, iron. You know, the ingredients for planets, the ingredients for life. And when they eventually exploded, they seeded the entire cosmos with the building blocks for everything that came next.
Now, I know this is a spectacular story, but it probably sounds like just a cool theory. How can we possibly know any of this is actually true? Well, because we have a photograph, literally a baby picture of the universe.
It's called the cosmic microwave background, or CMB for short. It's this faint afterglow of creation, light that's been traveling across space for over 13.7 billion years just to reach us. It is a literal snapshot of what the universe looked like when it was just an infant.
And you want to know the best part? It was discovered completely by accident. In 1965, two astronomers were just tearing their hair out over this persistent hiss they kept picking up on their radio antenna. They thought their equipment was broken. They checked everything. They even, and this is a true story, cleaned out pigeon droppings from the antenna, thinking that had to be the source of the noise. But the signal was still there, and it was coming from every single direction in the sky, all at once.
So here's where the story gets really mind-blowing. When we finally managed to map this ancient light with satellites, we saw it wasn't perfectly uniform. It was full of these tiny hot and cold spots with variations of, you guessed it, 1 part in 100,000. It was the exact pattern that the theory of stretch quantum fluctuations predicted. The evidence was right there staring us in the face.
This is the smoking gun. We're not just guessing here. We can literally see the imprints of those original quantum whispers. We can see the seeds from which every single galaxy, including our own Milky Way, eventually grew.
So the next time you look up at the night sky, just remember this. This whole grand cosmic story, every star, every galaxy, every single atom that makes up your body, it didn't start with a bang. It all began with an almost imperceptible whisper in the silence.
The universe is still expanding, still evolving, still carrying that ancient echo of its quiet birth. Which, of course, leaves us with one last big question to chew on. If the universe had such a quiet beginning, what kind of ending is waiting for it?